Experiment 6, that is closed traversing. In this experiment we are going to conduct the closed traverse. Closed traverse means after carrying the surveying work, the end of the survey work, that is the end point of the surveying work, will close with the or coincide with the starting point of the survey work, that is called as the closed traverse. Closed traverse is very helpful in case of the town planning. So here pentagon is considered as the closed traverse. So we are going to conduct the closed traverse. The first line of the traverse is the direction of the first line of the traverse is measured with the help of prismatic compass. Here the first station of the closed traverse is there, that is station A. Now the station B is the second station. Now we are going to measure the direction of the line, that is the forebearing of the line with the help of prismatic compass. To set the instrument over station A and do all temporary adjustment, that is centering, leveling and focusing. After doing the temporary adjustment, note the forebearing first line of the traverse, that is AB. Now rotate the prismatic compass, bisect the station B. The forebearing of the line is AB is 36 degrees. Along with the direction, now measure the distance between A and B. The distance is 6.5 meters between station A and B. For checking the measured forebearing whether it is correct or wrong, now shift the prismatic compass over station B and take the back bearing. If the back bearing is equal to forebearing plus or minus 180 degrees, then it is correct. If it is not, then again shift the instrument over station A and repeat the same process to get the correct forebearing. Now place the transit theodolite over the station B to continue the closed traverse. After taking the forebearing of station A with the help of prismatic compass, now fix the transit theodolite over station B and do all temporary adjustment like setting up, leveling and elimination of the parallax. After doing the temporary adjustment, unclamp the lower clamp and rotate the instrument, bisect the station A. After bisecting station A, clamp the lower clamp. If there is any slippage error, with the help of corresponding tangential screw, accurately bisect the station A. After bisecting station A with the help of vertical circle clamp, rotate the or transit the telescope about horizontal axis and clamp the vertical circle clamp. Set the C scale reading as 0. By transiting the telescope, the line of sight AB will be continued in the opposite direction or produced in the opposite direction. Now measure the deflection angle between AB produced line and BC line. Unclamp the upper clamp. Rotate the instrument in clockwise direction to bisect the station C. For accurate bisection, use corresponding tangential screw. After bisecting the station C, deflection angle A scale. The A scale reading equals to 145 degree, 20 minutes and 0 seconds. Measure the distance between B and C. Distance between B and C equals to 7 meters. Now shift the theodolite over station C and repeat the same procedure. So the instrument is shifted over station C and again temporary adjustments are carried out. After doing the temporary adjustment, with the help of lower clamp, bisect the station B. Station B is bisected. There is slippage error, use corresponding tangential screw. Now with the help of vertical circuit clamp, transit the telescope about 10 axis or horizontal. See you later. with the help of vertical circle clamp. Plunge the telescope about horizontal axis. Now the direction of the line will be produced. The line will be produced in the opposite direction. Now measure deflection angle between line CD and DE by unclamping the upper clamp and rotating the instrument. After bisecting the station E, note on the reading, that is the deflection angle. Deflection angle equals to 50 degree, 11 minutes and 20 seconds. Now measure the distance between station D and E. Distance between D equals to 5.8 meter. Shift the instrument towards station E. The instrument is shifted towards station E and all the temporary adjustments are carried out. Now bisect the station D with the help of lower clamp. After bisecting the station D with the help of vertical circle clamp, transit the telescope. The line of sight will be produced in the opposite direction. Now measure deflection angle between produced DE line and EA line. Unclamp the upper clamp and swing the instrument in clockwise direction. Bisect the station A. This is after bisecting clamp the upper clamp. For accurate bisecting, use corresponding tangential screw. Read the vernier reading. The deflection angle between the DE produced and EA line equals to 87 degrees 0 minute 0 second. Now measure the distance between E and A. 5.5. The distance between E and A equals to 5.3 meter. Now calculate the forebearing of all the lines with the help of deflection angles. After calculating, plot the traverse. If the end point of the traverse not meet the starting point of the traverse, there will be a closing error. That closing error is eliminated by transit rule and Bodich's rule. For closed traverse, after taking the field observations, now we are going to find out the forebearing of each lines with the help of measured deflection angles at each stations by using theodolite. The forebearing of first line equals to 36 degrees 0 minute, which is measured by using prismatic compass, whereas the station B, the deflection angle is measured. The forebearing of BC equals to forebearing of the previous line, that is the forebearing of line AB, and deflection angle at the station B equals to forebearing of BC equals to 181 degree 20 minutes 0 second. Then forebearing of CD equals to forebearing of BC, that is the previous line, forebearing of previous line, plus deflection angle at C. Then 181 degree plus 20 minutes 0 second plus 80 degree 11 minutes 20 second equals 261 degree 31 minutes 0. Similarly, all lines forebearings are to be calculated. If the deflection angle is measured in anti-clockwise direction, then deduct it from the previous line forebearing. If the deflection angle is measured in clockwise direction, then add the deflection angle to the forebearing of the previous line. So after getting the forebearing of each line, now calculate the latitude and departure of the each lines. Here line AB having the distance 6.45 meter and 4 bearing equals to 36 degrees 0 meter and 0 second, then latitude becomes 5.218, whereas departure becomes 3.791 meter. Then line BC having the distance 7 meter, 4 bearing equals to 181 degree 20 minutes 0 second, and latitude equals to 6.998 towards south, and departure 0.162 towards west direction. Similarly CD, DE and EA latitude and departures are calculated. Sum of latitude and sum of departure should be equals to 0. Then the end point will be made the starting point. If there is any number, that is latitude having some quantity or some magnitude and departure also having some magnitude, there will be closing error. The end point should not meet at the starting point. Here after summation of the latitude, we get the plus 5.512 meter, whereas after adding the departure we get minus 2.754. then there is a closing error. Here in this diagram we are observing that the latitude having plus 5.512 and departure having minus 2.715, then there is a closing error. Now it is required to eliminate that closing error. Independent coordinates are calculated latitude and departures by assuming the coordinates for station A as 100, 100. Then we are going to plot the closed traverse for the assumed latitude and for the assumed independent. In this graph we are observing that the end station should not meet at the starting point of the traverse because of the closing error, that is summation of latitude having plus 5.512 and summation of departure having minus 2.75. From these values the end point should not meet at the starting point. Now it is required to eliminate this portion, that is sum of latitude and sum of departure should become 0, then only this point meet at the starting point. For that purpose we are going to transit rule and Bowditch rule to eliminate that error. First we are going to Bowditch rule. According to Bowditch rule, correction to latitude or departure of any side equals to total error in latitude or departure into length of that line divided by perimeter of the traverse. The perimeter of the traverse equals to 30.36 meter, that is adding the length of each sides, that becomes the perimeter, that is 30.36 meter. Here the total error in latitude equals to plus 5.512 and total error in departure equals to minus 2.754. For the correction, that error becomes negative, positive error becomes negative, whereas the negative becomes positive in the case of correction. Here correction to latitude, AB equals to total error in latitude is plus 5.512, that is error. For correction it is taken as negative, minus 5.512 into length of that side equals to 6.45 meter. First line length equals to 6.45 meter divided by perimeter of the traverse. Perimeter of traverse equals 30.36 meter, that equals to minus 1.17 is the correction. Here minus 1.17 is the correction, means from the 5.218 latitude deduct 1.171, that is the corrected latitude, that equals to 4.047. Similarly departure also, AB equals to plus 2.754. Here the total error is minus 2.754. For correction it is taken as positive sign, plus 2.754 into, here 6.45 is the length of the AB line and 30.36 is the perimeter, that equals to 0.585 plus 585. Here the correction is plus, so departure 3 in the departure 3.791 meter, add the 0.585 meter, that becomes the corrected departure, that equals 4.376. Similarly correct the all latitude and departure by using Bowditch rule. Balanced by transit rule. According to transit rule, correction to latitude or departure of any side equals to total error in latitude or departure into latitude or departure of that side divided by arithmetic sum of the latitude or departure. So here arithmetic sum of the latitude equals to 21.176, means neglecting the signs, adding all the latitudes, and here also departure, adding all the departure, we get the arithmetic sum. arithmetic sum of departure equals to 17.296, arithmetic sum of latitude equals to 21.176. Then correction to line AB equals to minus 5.512 because error is plus and correction is minus into 52118 is the latitude of that line. Here latitude of that line is 5.218 divided by arithmetic sum of the latitude equals to 21.176, that equals to minus 1.358. From the latitude 5218 deduct 1.358, we get the corrected latitude, that equals 3.860. Similarly for departure, AB equals to plus 2.754 because here the error is negative and the correction is positive, into 3.79 is the departure of that line divided by arithmetic sum of the departure equals to 17.296, that equals to 0.603. Add this value to departure 3.791, we get the corrected departure, that is 4.394. Similarly, calculate all the corrected latitude and departure and add the corrected latitude and departure, we get the zero values in the latitude and departures. By using independent coordinates, after calculating the Bowditch rule and using transit rule, we plot the traverse. After plotting, the end of the survey will coincide with the starting point when we using the Bowditch rule for correction, and also for transit rule is used for correcting the total error. Here also the end station of the survey will meet the starting point of the survey, hence the traverse is closed. The error is eliminated by the both rules, that is Bowditch rule and transit rule.